Okay, 3.3 is just problems related to sine, cos, and tan, which we've been working on for the last 2 days. So let's look at an example of the question. Two adjoining properties are bordered by 3 roads, as shown in the diagram. The property owners agree to put a fence around and between both lots. What total length of fencing is required to the nearest meter? Okay, but for the most part, the difficult part of this section will be reading and trying to draw your triangles. I think the majority of you, the trig itself is the easy part. It's just drawing the initial triangle and then labeling it properly so that you can get the rest of the information. So when they give it to you, I don't suspect that you're going to have too much to worry about. So triangle number 1. Is that 61 degrees here. We have W and Z, so we don't know either of those. Triangle number 2. Now remember that we have to have at least 2 pieces of information in order to solve. And 2 pieces of information, at least one of those has to be a measure of a side. So we have that, Y, and X. Okay. So in order to solve this, we need to find out W, Z, X, and Y, and find out what their distances are. So let's start with this triangle, and let's solve for Y. Okay? Where in relation to the 37 degrees is Y? Opposite. And where is the 82 in relation to 37? Which one is opposite over adjacent? Tangent. So I'm going to start with that. Tan of 37 degrees is equal to the side opposite, which is what? For me? Y. That's right. Over 82. How do I get Y?
82 divided by 9.
So 37, tan 37 times 82.
Tan 37 multiplied by 82. You have to take the 82 up to the other side. And what do we get? Everybody have your calculators out.
61.791.
61.791.
1.791.
Okay. Now that guy is pretty important to us. How come? Why is it the important side?
Side triangle.
Okay. But what? Say it again?
You can find the hypotenuse.
I can't find the hypotenuse, but what else can I find? What else does it allow me to find? Nope, that is the height.
The angle.
Nope.
The length of the.
So the height on the other side.
Exactly what you two said. That is the length of this side here, correct? So now that allows us to find W and Z as well. So that's why it's the important side to us. We need to find all of those sides, but on this triangle, we had no other side length until now. Now that we have Y, that is this length right here. Okay? So it allows us to find Z and W. All right, so let's find X next then. Okay? Where is X in relation to 37? Where is 82 in relation to 37? Which one is adjacent over hypotenuse? So the cos of 37 is equal to the side adjacent, which is
Adjacent over
82 over X. How do I get X?
82 divided by cos 37.
That's correct. 82 divided by cos 37.
102.675.
sure you're using your calculator right now. Everybody needs to be calculating these to make sure you do them right. Yeah, I guess so. All right, let's find W next now. Where is W in relation to 61? Jason, where is 61.791 in relation? Opposite over adjacent is what? 10. So I'm going to go tan 61 equals 61.791 over W. How do I solve for W?
61.791 divided by 960.
Switch these two.
34.251.
We agree? Everybody needs to punch that into the calculator. Just make sure we got it right. 61.791 divided by 1061. Anybody not get it? So I can look at your calculator. Okay. I need Z now. Where is Z in relation to 61? Where is this? 61.791. Where is it in relation to 61? Opposite. So which one are we talking? Sine. So the sine of 61 is equal to 61.791 over Z. Z equals. Somebody other than Rory, tell me how to solve for Z.
Switch tan 61 and W. So we divide 61.791 into tan 61. And
Not
you
tan, no.
sin 61 and you sine. And you get 70.649.
Good. 70.649. Good. Yeah. Any questions? Any at all? I'm doing the same thing each time. What am I doing each time? What?
Figuring out which one you have to use.
And how am I figuring out which one I have to use?
Using your
Triangle you have, or the degree you have,
And then doing what?
probably moving on in the formula.
Yeah, before that though, how do I decide which trig ratio it is?
you use the information that's given to you and to figure out which one, if it's opposite hypotenuse.
Yes. What have I done each time? I ask myself the two sides that I need to work with, I ask myself where are they in relation to the angle? And that will tell me every single time which trig ratio I'm using. Okay? So every time I do this question, I do it the exact same way. Ask myself. So now I need to add up x, ED2, y, z, and w to get the answer for the total area or total perimeter, which is the fencing. And add them all together and you get 351.37 meters of fencing. Okay? We're moving through this fairly quickly. Trigonometry is a pretty important part of 11 and 12 pre-calculus. So we want to make sure that we have a good handle on right-angled trig. So if you're struggling with it, we need to slow it down a little bit and answer questions. Pardon me? 351 point something? Okay. Any other questions about this guy? How many of us are confident that we can do right-angled trig right now? Okay. How many of us are so-so? And how many of us don't have a clue? Morgan, you still struggling with this?
Yeah.
Okay, Morgan. Let's try another question then. We're going to work with Morgan here. The rest of you can follow along. Let's take question number 1 at 48, Morgan. 2.2.
Uh-huh.
Everybody here.
You got it?
I believe I have an angle, 7 degrees. All right. Morgan, we're gonna solve this triangle. The first thing I want you to do is tell me what angle B is, please.
The one on the bottom there,
Yeah. Yes. What is the actual value of it?
oh, 180, 23.
Very good. How did you get that, Morgan?
I took 180, take
Yes.
away 90, take away 67.
Very good. There. You're a third of the way through this already. Okay?
Okay.
All right, now, which sides do we have to solve for, Morgan? Which sides?
C and A.
C and A. Very good. All right, let's start with A, Morgan, okay?
Okay.
This side right here, where is it in relation to 67 degrees?
It's opposite.
It's opposite?
Actually, no, it's adjacent
It's adjacent, because why?
because it's right beside.
Okay, so then what is this guy then, at 2.2?
It's adjacent.
So
No.
can I have two adjacents?
Yeah, but A is the hypotenuse.
Very good, Morgan. Okay, so I agree with you. This is the hypotenuse right here, right?
Right.
And that's the adjacent side.
Yep.
So do you know which trig function I'm going to use? So here's what I need you to do, Morgan.
I don't know if it matters, but C and A should be
Cosine.
switched.
No, that's okay. Yeah, thank you. Which one is it, Morgan?
Cosine.
The cos? All right, so the cos of angle 67 says that I take the ratio of the side adjacent. What's the side adjacent to 67, Morgan?
22.2.
And then I'm going to divide that into my hypotenuse, which is
A.
A. All right, Morgan, I need to solve for A now.
So we do that flip, and then it'll be 2.2 divided by cosine of 67.
Excellent work, Morgan. I'm not to help you yet. So can you punch that into your calculator, please? Everybody else do the same so I get the right answer.
.630.
Excellent. We all agree? Awesome. So far, so good, Morgan. Okay? You know more than you think you do. Okay, where is this guy in relation to that?
Opposite.
Opposite, because it's across from it. You agree with me?
Yep.
Yeah, okay, good. Where is this in relation to that?
2.2 is adjacent.
2.2 is adjacent. Which one is opposite and adjacent?
Tan.
Tangent. So let's rewrite it again. Tan, the angle I know, which is 67 degrees, is equal to C over
2.2.
2.2. Now I need you to solve for C. How are you going to solve for C?
2.2 times tan of 67.
Absolutely.
.518.
Okay. Now, Morgan, what's the last decimal there? 5.18 what?
2.
2.
3 at B3.
Rounds up to 3? Morgan, should it have rounded up to 3?
Yep.
Okay. Now, Morgan, how can I check this to see if I got it right?
Forget how you do it.
Okay. So what do I have here, Morgan? I have The measure of that side, the measure of that side, the measure of that side. You agree with me?
Mm-hmm.
And what do we know about the three sides in a right angle triangle?
Three sides,
In a right triangle.
90 degrees.
Yep, that's what 90 degrees is. So what do we know about the three sides? Remember, do you know what Pythagoras' theorem is?
Yeah,
A squared plus B squared equals C squared.
yeah,
You remember that?
yeah.
So if I took 2.2 squared and added it to 5.183 squared, what should I get?
5.630
Squared.
squared.
You agree with me?
Yeah,
Let's check that. Go 2.2 squared plus 5.183 squared, and tell me what you get. What'd you get?
and that's square root, right?
Sure, square root it and see what we get.
5.630.
You just did everything right. I didn't have to help you with anything. Okay?
Okay.
You got this. You got this. Alright? That's all you up there. Okay?
Okay.
Keep working at it. Alright? The best thing you can do is have that sine, cosine, tan beside you so you know which one is which. Just speeds the process up a bit.
Yeah.
Okay? Anybody else want help? Questions from yesterday maybe? You were to do 2-1 or 3-1 and 3-2 yesterday. Anybody have issues with any of them? Paige? Ooh, this guy. I remember this guy. Question 13 on page 46. Somebody attempt that yesterday? Did you get it? No? Anybody else attempt it? I didn't get it. A water gun in a splasher's water park is positioned at the center of the long side of a 10 meter by 6 meter rectangle. The gun can spray to a maximum distance of 7 meters. How much of the opposite side of the pool can be sprayed? All right. So what are you thinking? Let's talk about this as a group. How do I find out how much of the opposite side of the pool can be sprayed?
Would you find with the end of each individual triangle and add them together?
That's a possibility, for sure. For sure, that would be a possibility. You could do it for each individual one. Is there another way in which we could do it? I forgot how to do this question, so.
Can you use circumference?
If it's saying like just a stream that like just one line kind of that spring, and it gets like over the pool because it overlaps it. So just those little parts in the end is what they want.
Okay.
So I was thinking, like, they give you the radius of 7 meters,
Mm-hmm.
and then you could find pi, which is the circumference, so like 14 times pi. So then that would give you the entire distance around it, and then you'd have to subtract. You'd have to find the angles of a circle to find how much the distance of that line is, and then also find the angle of what's inside and what's outside.
Yeah? Long process. Well, I'm thinking we're only doing right angle trig right now, right? So there has to be something that we can get. So let's first of all do this. What's that?
Can't you just find like the areas like, of the blocks around it? It has like a right triangle on the bottom right hand corner.
Okay, that's more what I was gonna get at right now. Yeah. Okay, first things first, what's the area of the pool itself? 60 meters squared, right? Okay, so this is what I'm gonna go with, more or less what Rory's saying right now. Okay? So here's the thing, we need to find out, all right? If I look at, how do I want to do this? This is 7 meters here, correct? And let's say we go right to the corner here to start with. That's 6 meters right there. We know this is 5 meters here. So let's do it like this. All right. Let's find out what the distance from that 10 meters is to the very corner of the swimming pool. So this is the corner of the swimming pool right here. I want to find out what that distance is. Okay? So let's start with that. How do I find that distance? A squared plus B squared equals C squared. Okay, what is that distance?
7.8.
All right, so it doesn't actually reach all the way over there, does it? Right? It comes up a little bit short, which you can see from the diagram. It comes up a little bit short on that side, right? So what we want to do is we want to find now, instead of doing that, let's find this. In which this is 7 meters here, okay? This is 5 meters here. I want to find out what this distance is, because that's the height of that triangle, right? So if it sprays 7 meters this way to touch the edge of the pool, we need to find out what this height is, because it is not 6 meters, because 6 meters is to the end of it, right? So use 7 squared, subtract 5 squared, and what do we get?
4.89. 4.899.
99 meters. Okay. So what I've done is I have found the first triangle to the right of this. So if you look at your picture, and it sprays this way, and it sprays this way. Actually, it goes out, right? Goes outside of this, so I have to go a little bit higher. So that's what our diagram looks like, right? So what part of the pool so far doesn't get touched? Well, does this get touched down here?
No.
No? Okay. How about over here? That doesn't get sprayed either, right? Okay, what about those two corners? Do they get sprayed? Does the 7 meters reach all the way to that corner there? No. So we don't have this either, do we? Correct? Okay, so how do we figure this out then? Well, let's start with the easy part. That's this triangle here and this triangle here. Let's get the areas of those two. So there's 2 of them, right? And they're going to have the same measurement. So it's a half times my base, which is 5, and my height is 4.899, correct? So that gives me an area of what?
24.495.
24.495? Is that what you said?
Yeah, almost quite.
That's for both the triangles.
That's the bottom one, sorry.
That's total?
Yeah.
Yeah, that's what I want, that's fine. Okay, so that's both of them. So I can subtract that off in here. Now, how do I find out what that is right there? Let's say that's a mini triangle. How do I find that measurement right there? Well, what's the height of it?
The remainder of the 7 meters.
The what?
Take 7.8.
Would it be the remainder of the 7.81?
Or would it be just 6 take away 4.89?
Yeah.
I agree with you. For that part. We're gonna get to the other part. I think you still need your numbers, but this guy right here, this length, from here to here, and here to here, this whole length is 6, agreed? And then right to this point was 4.899. So this little bit here is 6, subtract that. Does that make sense to everybody? Okay, so let's do that. That gives me 1.101. Okay. All right. Now, we got to figure something else out. We got to figure out this length right here, which is this length right here. So how am I going to do that? Any suggestions? What do I know? That's one number I'm going to have to use for sure. What's this distance from here to here? 7? I agree. And then across, and then down here, right? If I just went straight up, okay? How long is this guy right here? Nope. To here is 7, right? What is this guy? 6. Okay? So let's find out what this is right here. What is that distance? So 7 squared subtract 6 squared.
Six?
What do you get?
13.
No.
Yeah, 3.60.
What is it?
3.605.
3.605.
6.
6. Okay, so 7 squared, which is 49, minus 6 squared, which is 36, which is 13, and then the square root of 13 should give you 3.606. We're okay? All right. What's the distance from here to here? What is it? 5. So then what is my little guy distance right here? Which is?
1.39.
So that is the measurement from here to here and here to here. Let's get that triangle area right there. So that's area equals 2 times a half times my base, which is 1.394 times 1.101 equals. So basically you're taking 1.394 times 1.101 and what do I get? 3, 5. So also subtract that from up here. And the answer for A then is 60 subtract 24.495 subtract 1.535.
No, because you still have to subtract the amount of water that is over, not hitting the pool on the top, right?
Nope. I'm only focused on inside the pool right now. If you're focused on the outside of the pool,
Oh, yeah.
I didn't go past this, did I?
You're right.
Everything just stopped inside the pool edge, right?
I was thinking about that.
Okay, so what did we get there? 60 subtract 24.495 subtract 1.535. 32, 33. 53. Point 970. Let's make it 970 then. All right, so that is how much of the swimming pool that sprinkler is not hitting. The B part says what?
How much of the opposite side cannot be sprayed?
So how much of the opposite side of the pool can be sprayed?
You have to subtract the,
That's how much it is right there, right? So then how much can't be sprayed? 24.495 plus 1.535 would get you the answer for that. It's a long process for this question. Not an easy question. You won't see any of these questions that are in the extend on tests. They're just there to test your ability while doing everyday work. Okay? So a question like that, you're just working at it just to see how you can do with it. And out over and above. All right?
It says, like, on application 15A, it says the water guard can spray the middle 7.2 meters of the opposite side.
Oh. So we needed to add this. The question in A actually only asked us this right here. Asked us what that distance was. How much of the opposite side gets sprayed? So it's 3.606, add 3.606. So we found out way more than we needed to. Okay? And then how much of the opposite side cannot be sprayed? That's from here to here, here to here, which we have that times 2. So that's B.
Yeah, it says 2.8
What
meters.
spray distance would the gun need to spray to reach the entire other side? We solved it right here. 7.81. So we did way more work than we needed to. Way more work than we needed to. It was just everything we needed to find all that information in order to find areas. Okay? Alright. Anything else this afternoon? Okay, then what you need to do is get through 3.3. Tomorrow we review. I will have a pre-test for you tomorrow. I will have an assignment for you for Friday, or tomorrow, probably it'll be done. So you'll have an assignment to take home and do this weekend. Review tomorrow, Friday. Your test will be on Tuesday on this. So you'll have an assignment due Monday at the start of class, okay, that you'll get tomorrow. Or you'll get on Friday, except for the guys that are away Friday. And then you have pre-test, which I'll get you tomorrow as well. Got it?
Yeah, next week I will be here Wednesday, Thursday, Friday. I can make revisions.
no, neither will I.
So
So
It'll work
Tuesday,
too. Tuesday's the test. Got it? Okay. Get the rest of today to work on 3.3. No music. Phone should be on the back shelf today. This happened yesterday. Garrett.